is an event hosted by the Department of Environmental Sciences and Geology at Wayne State, also the College of Liberal Arts and Sciences. My name is Steve, and I'm going to be kind of asked here moderating. First, we're going to have a talk by Dr. Jay Ague, who's an alum of Wayne State University, received several degrees here, and he's going to give a presentation. And if you have any questions throughout, please put them in the chat, and I'll make sure that they're asked at the end during the Q&A portion. And if you need further follow-up, we'll unmute you and ask when we're at that portion. But we're just really honored to have Dr. Ague here today. He received his bachelor's from Wayne State in 1981, his master's in 1983. He then went on to receive his Ph.D. from UC Berkeley. And his focus is on studying the metamorphic and igneous rocks comprising the deep roots of mountain belts, focusing on heat and fluid transport. And he studies the implications for earthquake hazards, volcanism, economic mineral deposits, and the roles of mountain building and subduction in global carbon and climate cycles. He teaches at Yale University, where he's an assistant professor, and he's the Henry Barnard Davis Memorial Professor of Earth and Planetary Sciences. He's also the Curator-in-Charge of Mineralogy and Meteoritics at the Yale Peabody Museum. So I'm going to let him take it away and show his presentation. Again, please put any questions in the chat throughout.
All right, are we good? Can you hear me? All right, well, thank you. Thank you for that very kind and thoughtful introduction, and also the invitation. I'm really delighted to be here. I think the last time I gave a talk at Wayne was in 2013, so almost a decade ago. It's nice to be back, even if it's virtual. Lovely to be here, and I'm looking forward to the opportunity to share some thoughts today about my education at Wayne and some of the critical sort of junctures in my career development that I think shaped me as a scientist, and highlighting some of the things that I think are actually unique to Wayne State during those times, and I'm sure there are many unique aspects today as well. So yes, so as was said in the very kind introduction, okay, now I've got to figure this out. I think it worked. All right, great, thank you. I like to see the thumbs up. Lets me know I'm on track. I study high temperature, high pressure rocks in mountain belts for the most part. And there's many implications for that, that stem from the heat, the pressure, the chemically reactive fluids that move through rocks in such settings. So this is a photo from the Washington Cascades, the Mount Stewart area. And just looking at these mountains with this alpine landscape is really awe-inspiring. And for someone who grew up in the Detroit area, a few hundred feet above sea level, views like this still inspire me. Now, when I was a student at Wayne, and I think still to today, there was a pretty strong emphasis on field trips. I know there's some classic field trips to the Bancroft area, Mineralogy, and so on that have been formative experiences for a lot of you folks. And that was the case back in the 1980s when I was a student. Now, in the local lower Michigan area, the outcrops, they're not quite like this. But I gotta say, we did the best we could with what we had, and we learned a heck of a lot. And those of you with either good eyes and or good memories might recognize some of the people in this photo. I don't know who's all in the audience, but these are three professors that I had at Wayne. This is Stuart Birnbaum. This is Robert Furlong, who was chair of the department for a very long time. And this is Alan Morris here, all of them playing pretty formative roles in my development. And I'll highlight Stuart and Alan as we go along. So yeah, they took us into the field at every opportunity. And when it turned out that, you know, things needed to be seen that weren't in Michigan, we went elsewhere and all over the East Coast, actually, on a number of field trips. This one was to New York State, seeing some spectacular exposures of metamorphosed mud rocks. So these are slates, the slate belt. Another important highlight for me for these field trips and also my education in the department was that that's where I met my wife. And we've been together for gosh knows how long, since the early 1980s. So that was nice too. So in terms of field work, one of the things that was very formative in my development was a field camp. And Wayne State University ran a camp out west. And growing up in the Detroit area, I had never seen anything like this before. And so when I went out in 1980 to places like the Badlands or the Black Hills, the craters of the moon in Idaho, Yellowstone, here's Old Faithful, Wyoming, place called Sunlight Basin in Wyoming. This literally just blew my mind. And the fact that, you know, so much Earth history was preserved in the United States and in rocks that were accessible and you could just climb around on and you could map them and you could measure them was transformative for me. And so when I got back from a field camp, I was anxious to do more. And at the time, there, as I recall, there wasn't really a senior project or a capstone to the degree, but one of the professors, Stuart Birnbaum, had a small research project looking at the rocks in and around Niagara Falls. And, you know, I was just very, very anxious to get involved in more geology, given what I'd experienced out west. And so Stuart was very, very kind and invited me to participate in some of his field work in and around Niagara Falls. And that involved the Lockport and the DeQ formations. And now I've got a whole bunch of stuff on my screen. I'm not sure exactly what you're seeing. But over here, I'm sort of moving my cursor around, sort of a geologic section through those rocks. And they're special because they hold up Niagara Falls. And we went to the field and I took very, very careful notes, which is something that I learned at field camp. And Stuart and also his colleague, Alan Morris, really showed me how to perfect these kinds of observations. And I still have all these notebooks to this day and occasionally refer back to them, believe it or not. And so anyway, Stuart was interested in these things called stylolites. And to be frank, I didn't have too much of an idea of what stylolites even were. I heard about them in sedimentology, but Stuart took me under his wing. And we did some work and it was very interesting. And what the rocks look like is here. This is a cut slab. This is the Lockport Formation above and the DeQ Formation below. And what was originally a flat sedimentary contact has become this interdigitated stylolite contact, all right? And the idea of the research was to try and figure out some of the ways in which this very interdigitated look developed and what it means. Now, there's a reason to care about such things. When this process happens, the rock partially dissolves and reprecipitates, which changes the porosity and the permeability of the rock. And this influences the migration of subsurface waters, the migration of petroleum, natural gas, and also has implications for the sequestration, potential geologic sequestration of anthropogenic carbon. So there's a lot wrapped up in these features. And, Stuart said, well, do we have this project? Are you interested? And I jumped at it. And so we went there. Alan Morris accompanied us, made a map. Here's Niagara Falls. That's where we got the rocks. That's where all my notes are from. I learned how to make petrographic thin sections. And here's one of these stylolite features preserved in a microscope slide. And I also was able to start using some of the more quantitative things that I'd learned in my other classes and apply them to geologic problems. Up until this point, my math classes and physics and chemistry were great. They provided a strong foundation, but I didn't really know, I didn't really have an example to apply them to. But this actually became the first example that I was able to work on. And we did some calculations involving stress and dissolution reprecipitation reactions and came up with a model for stylolite formation. Long story short, very low surface energy, very large fossils dissolve slower. And we typically found them in the tips of these stylolites, and we thought that there would be a kinetic effect associated with that. And this led to a presentation that I made at the Geological Society of America in 1982. And I still have all the slides and everything associated with this, my very, very first scientific presentation. So what did I learn from this, and what are the takeaways? Well, first of all, you never can predict the future. So although that was in 1981, I am still fascinated by this problem. And we have fancy words for it, non-hydrostatic stress and da-da-da-da-da. But we're still publishing papers on it, and my students are learning about it. And it remains as a research frontier for me to this day. So when there's an opportunity, take it. You never know where it's going to lead. Like I say, this is something I'm still working on today with very, very important implications in the geosciences, geochemistry, and geophysics more broadly. I also learned that the quantitative reasoning in chemistry, math, and physics that I was learning both in departments outside of geology and within geology from professors like Furlong and Ronca and others, this could actually be applied to help solve geologic problems. And Stuart pointed the way for me to do this, and Alan encouraged me as well. More about him soon. And then I also learned that, I could come up with a new result and present it at a major scientific meeting. I would never, ever believe this if it was not for the mentoring that I'd received as part of this senior project. And as I mentioned before, this topic of pressure solution and non-hydrostatic thermodynamics is something I still care about today. So it made a profound impact on me. And making thin sections, not everyone's cup of tea, but this fostered a real love of petrography, looking at rocks under the microscope. And I still make most of the microscope thin sections for my lab research group today. And it comes in handy because I don't know if you can see me, but I have a new edition of our petrology textbook out with Tony Philpotts, and I've got tons of pictures of my nice thin sections. So you never know when these things are going to come in handy. So I wanted to do more, and science was not in my immediate family's background, and so I didn't really know what a scientific career would look like. But I realized that a bachelor's was great, but I probably needed more. And so at that point, starting to think that I really was leaning in the scientific direction, but still had some thoughts about, well, yes, no, still thinking about it. I tried to seek out a master's project, and that's where I really got to interact strongly with Alan Morris, a faculty there at the time. And Alan had a big National Science Foundation grant to study the geology of Spitsbergen. Spitsbergen is the largest island here in this group of islands known as the Svalbard Archipelago. And one of the fascinating things about these rocks is that they represent some of the most northern exposures of the Appalachian Caledonide mountain chain, sort of northern extension of Baltica, which extends down into Norway. And we, of course, are on the other side of all this activity that was happening, several 100 million years ago as ocean basins were forming and closing and so on. There's a fascinating history. So I interviewed with Alan, and it worked out. I was able to go to Svalbard on his expeditions and see these rocks for myself. Really fascinating. So these were rocks that I hadn't really worked on before. These were metamorphic rocks formed by the heat and compression of ancient mountain building events. So if you go to Svalbard today, typically you will first end up in Longyearbyen, which is around here. Longyear, very, very aptly named. And if you go there today, you'll encounter this university center, research center here in Svalbard, which is staffed and overseen by a consortium of Norwegian universities as well as the government. And, it's beautiful. They have look at this cafeteria here, and these wonderful laboratories for Arctic science, and these charming little homes to live in while you're visiting. It's really a special place. When we were there, yeah, not so much. Tents out beside the airport. We had to stay in these tents because our rations, our food supplies were late arriving. So I think we stayed out here a week or a week and a half. I can't remember quite how long it was, but we eventually were able to get out into the field. In those few days, I explored a bit around the town of Longyear, which at the time looked mostly like this. It turns out the region is known for its coal mining. As you know, coal tends to develop in very warm, wet, tropical, humid environments. That's a far cry from what it's like up there today. But nonetheless, it's there. And it was our understanding that they actually did most of the coal mining in the wintertime, because the permafrost was frozen solid at that point, and it was easier to work the ground. You see some of the mining operation here. And of course, during the winter time, it's like what, -20 to -40 degrees and pitch black. So working there under those conditions is definitely must be an acquired taste. That's for sure. Sometimes you might get asked, was it -30? Is that Fahrenheit or Celsius? You say, well, it doesn't matter because that's where the curves cross. All I know is that that's just really cold. When we're there in the summertime, this was, yeah, summer months, it was a bit warmer because a branch of the Gulf Stream gets up there and keeps things right around freezing and drizzling. So it's ideal hypothermia weather, but you keep your wits about you and you'll be okay. Always packed a couple of thermoses of hot soups and teas and so forth with us when we went out into the field. So our supplies eventually showed up on a boat and we were ready to go. And we took a helicopter and flew over the landscape, and very, very close to the ground, I might add. It was a fairly hairy ride, as I recall, and you are out in absolutely the middle of nowhere. Flew over these fantastic glaciers. You know, it's hard to get the scale here, but this is, you know, this is around 100 foot, a bit more. Remarkable, just spectacular. You could drive up to these on your Zodiac boat and just be awestruck by these glaciers in the water. And so this was our field site. We arrived safe and sound and unpacked everything. You see our tents. This is our, it's not fully assembled, but this is our Zodiac, our inflatable boat that we use to zip around the fjords. And then this right here is a so-called climbing hut, which has been there for gosh knows how long. There it is. You see it has a chimney. It had a cast iron stove in it, which we used for cooking, boiling the water, cooking all of our freeze-dried whatever we had. And what we used for fuel was driftwood. So, you know, I think we had a little bit of propane or things like that. But for the most part, cooking on the cast iron stove was what we did. And that used firewood, which we'd collect on the beaches, bring it in, saw it up, cook, eat, fall asleep, and then, you know, go back out in the field, you know, wash, rinse, repeat, day after day. So I think we were out there for 6 or 7 weeks. Water, of course, the fjords were kind of salty. Couldn't do much with that. So we had to get the water from the melting glaciers and the glacial streams. So it was pretty intense field work, but magical, absolutely magical. We encountered some Norwegian researchers along the way, some Russian geologists. The Russian geologists kept asking us if we wanted to take a shower because that was one facility we didn't have. And I suspect we might not have been that pleasant to have been around. Anyway, when we were done, we were tired, but we made it out. There's me, it's Shelley and Cheryl, Les Kennett, and then Alan Morris right here. Made it out. You can see the winter is closing in, the snows are starting. And because, you know, basically everything that we were wearing was so nasty after a couple of months out in the field, you have to have a ceremonial burning of everything you don't want to take back. You can see the official WSU gasoline canister right here. And Alan is burning his wellies, his Wellington boots, these rubber boots that are very nice and they're waterproof. But after 2 months, they are just nasty. And, you know, I don't think they'd even let you bring them on an airplane or something. So you have to dispose of them in some other way. And this is the way that you do it. But what were the rocks like? I mean, the rocks were really something. These are deformed and metamorphosed rocks. These are rock layers that accumulated, sedimentary layers that accumulated in an ancient ocean basin, and then were deformed and metamorphosed during Caledonide orogenic activity. This produced metamorphic minerals. It produced interesting structures, the folds you can see. It also produced these quartz veins. And quartz veins are regions where a large amount of fluid that's developed by dehydration of the rock mass. These veins are where the fluid exits. And this has been something of great interest to me, as well as the rocks themselves. So where did this go? Well, I got a master's, and I actually was able to write a paper. This is my first paper that I wrote with Alan. And I still have paper copies of this today. I will treasure them to the very, very end for the duration. Looking back on this experience, again, take advantage of exciting opportunities. I had to petition Alan, and I interviewed to get on this gig, and luckily it worked out. I'm glad I was bold enough and worked up the courage to do that, because it led to something that was pretty special. Another thing that I learned, and is very important as a scientist, is that when a research project starts, there are many unanswered questions. That's why I call it research. And so a key element of a research career is being able to be excited when you're on the edge of knowledge or on the edge of the unknown. In other words, working on topics that people don't know the answers to. And this became really ingrained in me, and is something that I like to do, love to do. It's my passion as a research scientist. Now, it's not for everyone, and it's good to have experiences when you're an undergraduate or maybe a master's student before going on into a PhD, because you can assess whether you enjoy being working in the unknown, or whether you would prefer some other aspect of science or some other career. It's all good. It's just that research science has this aspect of having unanswered questions that we address by the scientific method. And the more exciting the science, the more unknown it tends to be. I realized that now I could not only present results at meetings, but I could also publish findings in a scientific journal. Just as I said before, this is nothing I would ever have believed, ever, that I could do this. But the folks at Wayne encouraged me such that, I was able to begin operating like a professional scientist. And I really, really, really liked it. It also highlighted to me that writing and public speaking are essential to scientific communication. I mean, you don't have to be a great writer, and you don't have to be a great speaker, but you can improve, like I've hopefully have over the years with practice, and just being able to get your point across in words, either on the printed page or the electronic PDF or in person or on Zoom, whatever, is critical to what we do. And then finally, this field trip again exposed me to a whole new set of varieties of rocks that I didn't know existed. And I became particularly fascinated by them, deformed and metamorphosed rocks. And these have been most of my research and mentoring focus for the past 35 years or so. So I've been trying to take these lessons learned and apply them in my own career as I mentor students and teach classes. So these stars represent places that I've been. for research and teaching over the last 35 years or so. Certainly haven't been everywhere, but been quite a few places. I was really looking forward to going to China and over into the Tian Shan and the old Silk Road and so forth. That was 2020, and we all know what happened in 2020. So I haven't been there, and I would like to visit more places of the global South. I just have a postdoc who's finished up, Santiago Tessara, and he is taking a job down here in Chile. And he's leaving today, actually, so I'll say goodbye to him right after this talk. And so that'll give me a good excuse to go to South America, which I'm very, very anxious to see. And perhaps the best part of this, from the standpoint of both being a research mentor and an educator, is all the people that you get to interact with, the students, the postdocs, the other faculty, the geologists from other nations. And this is, I was just putting this together, and there are many, 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 many more, but if I put them all on there, it'd be so small you couldn't see anything. All of these people have played a critical role in my professional development, because, you know, I've in many cases learned as much or more from them as they've learned from me. So thank you, students. All right. So another thing that really influenced me at Wayne was museums and collections, specifically mineral collections, but all sorts of collections. And a critical person in that regard was Dave Lowry. I should mention that all of the field excursions that I mentioned previously, the Wayne excursions that I talked about, I mean, they would have never really gotten off the ground without Dave and his expert logistics and preparation, and field education too. I remember him instructing us in plane tabling out in Elk Basin during summer field camp. And Dave also, you know, probably really kind of saved the day for his expert advice. I remember packing up to go to Spitsberg, and he said, well, you know, you might need a few more tools. And yeah, boy, was he right. I'm glad we packed up what he provided for us. But if you go back into my deep history and try and identify where I got interested in science, it probably was the old Natural History Museum at the University of Michigan. I had an uncle that was going to school up there, and my parents would come out from Detroit and visit Ann Arbor every now and then. And whenever possible, we could go to the Natural History Museum, and it really, really captured my imagination in terms of natural objects and the power they have to educate and illuminate, you know, the history of our planet and life upon our planet. And when I was at Wayne, of course, Dave was legendary for his spectacular mineral specimens, which I got to see on numerous occasions, and those were really, really special. And I'm just so thrilled now that there is a geology mineral museum at Wayne. This is a very, very fitting legacy to all that Dave done for the department and geology and minerals in the Detroit area. You know, he's a nationally known, internationally known mineral collector. His expertise is widely valued, and this is just great. So when I came to Yale after getting my Ph.D. at Berkeley, I have many field stories from Berkeley if you want, but that's going to take up more time than we have. But when I got to Yale, I was very fortunate because Yale has a natural history museum, the Yale Peabody Museum. And At the moment, it's undergoing renovation. Here's a picture from today, actually. You can see the cranes and all the construction out in front. Here's an artist's conception of what it's going to look like. But I was offered the opportunity, I should say, to become the curator of mineralogy. And that position has now grown. So I'm the curator in charge of mineralogy and meteoritics for the museum. I also served as the museum's acting director for a time, and have just been very involved in the museum for many, 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 many years. A good part of that involvement and a really rewarding aspect was the ability to have my own mineral galleries of our own design. And the first one was the Hall of Minerals, Earth and Space, Homes, which opened in 2008. And then we had the David Friend Hall in 2016 with spectacular mineral specimens from around the world. And now these halls are undergoing a complete renovation. David Friend Hall is pretty new, so that'll remain more or less the same, but the specimens in it will rotate. And it's just another really exciting opportunity to engage with the public. And so, you know, the collection has spectacular things like this gigantic Namibian quartz crystal, or these fluorites, for example, aragonite from a cave deposit, or these very unusual forms from France, which we affectionately call the Michelin Man. This is if my collection manager, Dr. Nicolescu, was with me, he could tell me, I think this is probably about 5 foot across. I mean, these things are huge, and it's been a real privilege to work with them. And every object has a story. This is barite, barium sulfate from Cheshire, Connecticut. Should have put a scale in it. It's several feet across and weighs over 300 pounds. And this barite was mined in the 19th century. And there are miles of tunnels underneath the region just to the north of Yale, where they were mining all this barite. And apparently some of it was used for paper filler and white pigment. Barium sulfate is pretty inert. You know, it's not that chemically reactive. It's also super dense, really, really dense. And so it turns out another use for this powdered barite was in agriculture, but not as fertilizer. When you grind it up, it looks sort of like white powder. It looks like flour. And if you sell your flour by weight, you could salt in a bit of barite and you'd have a lot more weight there with less flour. Good old, you know, Yankee ingenuity. I don't know how well your bread and muffins would turn out if they're full of barite. Probably not so great, but at least probably didn't hurt anybody. This is a fulgurite. It's a fossilized lightning strike. And this is the fulgurite here. It's about 13 feet tall. You can see it here. And this was excavated from beach sands in northern Connecticut. Essentially, the ground surface is right up here at the top. The lightning hit, and then the electrical current went down through the various glacial layers here. And it's so hot that it fused the sands together into a glass, a fulgurite. This is one of the longest, if not the longest, in captivity anywhere. And I think it's just so magical because you can see the thing bend as it enters in and out of these various layers, which probably reflects differences in the electrical conductivity, and so on. Many other stories I could tell about this object, but we're anxious to put it back out on display once a museum is renovated. And then there are meteorites we deal with too. And this is one of the famous ones, the Murchison meteorite from Murchison, Australia. It fell in 1969. It's a kind of meteorite it's a carbonaceous chondrite. Actually, this is Murchis and this is Allende. They're both carbonaceous chondrites. And that means they have carbon in them. And you might say, okay, that's great. But there are some fascinating aspects to this carbon. One of the things they contain are nanodiamonds, diamonds that are far too small to see, sub-micron scale, but they're diamonds. And these diamonds represent stardust. They are objects that were floating around where our solar system is now before the solar system formed. So they're the only objects you can put your hands on that are older than 4.5 billion years. We don't know exactly how old these tiny nanodiamonds are. People are trying to date them. It's a difficult task, but we know that they're older than the solar system. That's just magical. Even more remarkable is these things contain organic compounds, carbohydrates, and even amino acids. Here's my only animation. There you go. Amino acids. And amino acids have right and left-handed varieties. Most life on Earth selects for one of those two varieties, a handedness. I believe it's the L-handedness. There are a few things that select for the other. Apparently there's some venomous cone snail somewhere, but for the most part, it's all one. If you look at the meteorite amino acids, they're about a 50-50 mix, which could have either formed or equilibrated in space. You can also look at the isotopic compositions of these compounds in terms of nitrogen isotopes, or carbon isotopes. And they are isotopes, I should say. And they are quite wacky. They are not anything you'd associate with normal terrestrial processes. So these are extraterrestrial amino acids. And amino acids are the building blocks of proteins. So does this have something to do with the origin of life on Earth? I don't know, but it's remarkable to be able to go on any given day into the collection room and examine such objects. All right. So I think I've already gone over time. Yes, so there's old Maine, and I miss it very much. My wife does too. And we want to, once this pandemic's over, we love to come back and visit a bit. But there are some things that keep the memories of Wayne close to home, some very, very personal relationships. That includes Professor Ruth Blake, who is my colleague here at Yale University. And she was a student at Wayne. And she was recruited by the same mentors I had, Stuart Birnbaum and Alan Morris, and worked pretty closely with Stuart. And you'll probably be hearing from her in another one of these talks in the not too distant future. So that's really wonderful. And also, I still have distilled down into a set of very compact notes in a binder. It's really beat up, and I've been using it forever, of all sort of the very, very key things that I learned as a student at Wayne, in bachelor's and a master's. And I refer back to this all the time. I still look back on what I learned and check to make sure I'm doing things correctly, particularly when it comes to field technique. I'm so grateful to have had those experiences. So to sum up, some overarching lessons. I think mentorship is key to where I came from, and how I got to where I am now. And at Wayne, it provided unique opportunities and the encouragement to believe that I could actually be a scientist. As I said before, This is not something that was in my immediate family. It was nothing I was really familiar with. But these folks, as I've discussed, and many others, had faith in me and believed in me and mentored me in a way that I could ultimately be successful. They provided a wide array of educational experiences and field trips and everything that you could imagine that they had to offer. And I tried to take advantage of it to kind of get to know the field as well as I could and make future decisions about educational pathways. When there is something that looks like an interesting opportunity, take it, just jump at it and see what happens. It's really difficult to predict what will lead to new outcomes and new directions. And the only way to find out is to immerse yourself in the opportunities that are present. And fortunately, when I was at Yale, and I try and offer these opportunities to my students, and looking back, it's remarkable how much I was able to benefit from similar experiences at Wayne. So one way you can learn if you want to be a scientist is if you're excited by cutting edge knowledge and the unknown. This is where state-of-the-art science thrives, and if you like that, that's great. Can also reveal what motivates you. You know, those experiences you might partake of, work in a lab or do field work or whatever, and you might say, well, you know, that actually isn't so great. But until you try, you don't know. And so those experiences really matter. And in terms of the museum, it really offers invaluable outreach and broader impacts experiences. And these are ways to communicate science to the general public. I learned this back in Michigan, and I continue to try and hold this up as an ideal as a professor here at Yale. That museums are really a crucial avenue for getting the word out, so to speak. And then I think really what I remember most about not only the folks I've talked about, but a lot of the professors I had, and some of the graduate student teachers I had at Wayne, is that they really did seem to care that the students learned. And that's just everything. Because a student, they know if you care, they know if you don't care. And if you care, and that comes through in the mentorship, it's something that they'll remember for the rest of their lives, like I will. So here's a shot from Norway, fieldwork earlier this summer. And thank you very, very much for the opportunity to talk to you all today.
Oh, thank you, Dr. Ague. That was incredible. Your insights, but also the images are some of the, I don't know, most breathtaking I've seen, especially like the lightning hitting the sand and
That's crazy, right?
in the map, and also just your really transcendent advice for students is really helpful for all students of any major or anyone really. So thank you for all that.
Well, my pleasure. My pleasure. Are there questions I could address?
Yeah, we had one, Dr. Basker, in the chair of the department. He said, in Antarctica, south of 60 or 65 degrees, no waste can be discarded or discharged into ocean waters. Were there any restrictions in, I don't know if I'm pronouncing it right, Svalbard? Were there any restrictions there?
Yeah, there were some restrictions, and if Alan was here, he could tell you all about that. But a lot of those crates you saw on the dock were us packing out material to be disposed of in a more environmentally less sensitive way, shall we say. You don't want to be doing too much to the permafrost because it's a very delicate ecosystem. So yeah, we had to pack a lot out is the bottom line.
Yeah. So how about that 100 feet, we have this thick snow, ice, and this was in 1980. So after now 40 years, is it still there, or it has changed a lot because of this? I mean, we see a lot of changes in the Arctic.
That's a super question, and I don't really know the answer to that for Svalbard in detail, but I can make a comment on the northern Shetland Islands, places like Unst, which are the northernmost part of Scotland, where we've done field work and interacted with the residents there. And some of them been there for, old timers, live their whole life on these islands. And I mean, these islands are places that have like 50 to 100 people as a population. And we asked them and talked to them about, the climate change. And they were quite frank about it, the snows and ice and everything that they used to have when they were growing up doesn't occur there anymore. And as many of you know, the regions that will be most seriously affected first by climate change are sort of the polar regions, and the sea ice is diminishing year by year. They're lovely they're beautiful photographs, but they're very scary photographs of how the sea ice has changed over the past decades.
Yeah.
And of course, Svalbard and Unst and all Greenland, all of these northern regions are part of that milieu.
Yeah, thank you.
Yeah, if anyone has any questions, please put them in the chat, or if you want to raise your hand and unmute, that also works too. I was curious.
All sorts of things I'm happy to talk about.
I think you said you met your wife at Wayne State. Was she a student? And if so, what was she studying?
Oh, she was studying geology too, and she now teaches science here in the public school system here in New Haven. So,
well, that's awesome.
Yeah, it was great. It worked out.
Yeah.
So you come once in a while. You have extended families. You visit this area.
Most of them have moved on to other places. There still are a few family members. We were thinking about visiting, a few years ago, but then the pandemic hit, and it's just, no. But probably in the next few years, we'll be coming by, and would love to say hi if that's possible.
Yeah, we'd love to have you back. Let us know if you are coming this side. We can arrange a few talks and meet with students.
Absolutely.
Yeah.
And the Lowry Museum is very nice.
Yeah, I'd love to see that. I'd totally love to see that.
Yeah.
I think there are some questions in the chat.
So Max, he just asked, what meteorite or mineral is your favorite?
Oh, that's a great question. Yeah, so my favorite mineral is garnet. Garnet. It's kind of a running joke in the department, actually, because me and my research group, we're always, just doing garnets. I have garnets, maps of garnets, chemical images of garnets, morphology of garnets on the wall here. I mean, they're just so cool. And the reason they're so cool is because they grow and they retain, in many cases, a record of what was happening as they grew in the rock. So you can use them to, decipher the pressure and the temperature of formation of your rock. You can date them. You can find out how old your rock is. You can use them to study fluid rock interactions as well. So, they're just great, from preservation of structural features to chemical features to isotopic features. You got me going. I can talk about garnets all day long. Meteorites, I think probably my favorite meteorite, well, the carbonaceous chondrites are just awesome. I mean, right? When you have things like those organic compounds from space, it's like, wow, it really kind of expands your mind. But there's another one called the Weston meteorite, which is the first scientifically described meteorite fall in the United States from the early 1800s. It was described by Silliman, for whom sillimanite is named, and his colleague Kingsley. And it fell in the western part of Connecticut, and it was all over the place, and people wondered what it was, and brought out some professors from Yale to have a look, and he brought back chunks of it. And at the time, the origin of meteorites was pretty controversial. People thought, maybe they could be like volcanic bombs that got hurled a long, long way. It's not such a bad idea, actually. Or they were extraterrestrial. And Silliman did a chemical analysis of this meteorite and found that it had very unusual, iron and nickel content, unlike any rocks that were really known at that time. And he said, well, it must be extraterrestrial. And it turns out he was right. And this was not a well-received finding everywhere. For example, Thomas Jefferson, who was around in those days, he didn't have, I guess, a great fondness for Yankee divinity schools. And it's apocryphal, but he said something to the effect that he'd sooner believe 2 Yankee professors would lie than stones fall out of the sky. So there's a lot of history associated with that object, and it's pretty special. We'll be putting that out on display again too when the museum is fully renovated, hopefully in early 2024. So if you're ever in the neighborhood, definitely give me or Stefan an email, and we'd be happy to show you around.
Oh, that's so nice. That's fascinating history there. Nora Beth asked, do you have a favorite place out of the places you visited?
I have, of all the places I visited, the most remarkable, the 2 most remarkable were Svalbard. It's really something. It's just gorgeous. And remote, and just, I can't say enough about it. The other place was Papua New Guinea, which is where I did my good part of my Ph.D. And that place was really a challenge. It was all known forms of malaria were there at the time. Actually, I have a few slides. If I share my screen again, I could show you. They're kind of cool, actually. Can I do that?
Yeah, that'd be great.
I promise it won't be bad. Yeah, so we were living at this place called Oktedi, which was up in the Star Mountains in the spine of Papua New Guinea. It was a mining camp, and we were living in kind of half of this double wide trailer for a couple of months, and it was just the strangest place. For example, the ground, because of all the mineralization, was not too amenable to a lot of the normal kinds of plants you might see. So there is a huge variety of these carnivorous plants all over the place. I mean, there were lots of insects and spiders, but there were these these carnivorous plants were there too. And I think part of the reason they were so successful is not only because of the biota, but also because they didn't have to get nutrients from the soil, which was full of things that could be toxic to a lot of more normal plant life. So it's a pretty surreal landscape, so a little shop of horrors kind of thing. And the insects and arachnids were just remarkable. So this photo is not super clear, but I'll tell you what it is. This is a telephone pole, all right? So typical height, 20 feet, whatever. And you can see these black specks. See those black specks? That is a communal spider web. they would build these webs of all different species of spiders, and they would blanket the landscape. It would be up to like a meter thick, and you'd have to hack through them with your machete and kind of fold them back. And you never knew which ones were the ones that were poisonous or were going to give you a bad bite, or anything. So that added a little excitement to the whole thing. But they also made these vertical or near vertical web masses. And so this is 20 foot up in the air. So you can still see these spiders, which gives you an indication of how big they were. So that was really something, I gotta say. So in terms of just an otherworldly experience, that would have been it. But places I've been, like Greece and New Zealand and Scotland and Japan, I mean, they're all beautiful and they're all spectacular in their own way. I hope I didn't take too much time there.
That was cool to see that photo. Terrifying. I would not want to walk through that.
Yeah,
web.
if you don't like spiders, it's not the place to be. No, not the place to be.
I see just one last question, and it said, from John, how long did you go and work in the field before you knew what you wanted to do your master's in?
In the field, like field outdoors field, or in the field of geology? Because it doesn't matter, because the answer is it was kind of simultaneous, because the field programs and the geology classes were kind of just linked up. Even for 101, we did a nice field excursion into Canada. It kind of went hand in hand. And so the more I experienced of learning in the classroom and then seeing how those geological concepts played out in actual rocks, the more and more I was drawn in and got involved and was more and more convinced that I wanted to do this. But again, you know, a lot of folks go directly from the bachelor's into a PhD. I did a master's in between, and I'm very glad that I had that experience. First of all, I could go to Spitsbergen, but also it eased that transition into the PhD, and I was able to finish the PhD faster as a result. And furthermore, it was, you know, full bona fide research, the Svalbard work, and it gave me the experience as, okay, do you like real research? And the answer turned out to be yes, I do. So I took advantage of that opportunity. Alan was very kindly took me into the field, part of the field team, and then it all kind of stemmed from that.
Well,
hope that makes sense.
Thank you so much. I saw, there were a lot of comments just saying thank you. I mean, this is one of the best presentations. So thanks for your time and all the imagery, and we really appreciate it.
Oh, my pleasure. I wish I was there in person with you all, maybe in a couple of years after a pandemic. I'm still actually, I got the COVID booster and I'm still actually kind of feeling the effects of it. So yeah, maybe in a couple of years we don't have to worry about this stuff so much. It'd be great to see all in person.
Yeah.
But I would like to thank all of you there at Wayne, both today, past and present, for making possible what I've been able to do with my life, and also my wife as well. She could have her own great presentation to talk to you all about.
Sure. Yeah. Thank you so much. We really, really appreciate for taking time and make an excellent presentation with our students. Only I wish, it's my mistake, I wish I had informed Dave Lowry. He would have definitely joined. And also Bob Furlong's wife, Bob is no more, but Rosemary would have also joined this. So, but we will make sure they get the presentation, the link, we will send it so they can watch. Yeah.
I think Stuart and Alan are still out there somewhere, if I'm not mistaken. But anyway, yeah, share it as widely as you like.
Sure. Yeah, I will ask. I mean, he went to San Antonio, right? I mean, UT San
They
Antonio.
were there, and yeah, and then Southwest Research Institute,
Just not far away from there. Yeah.
yeah, so
I see.
anyway,
Okay.
yeah, I'm happy to share.
Yeah, sure. Yeah, we'll try to track them down if we can. Yeah. Hey, thanks again.
Thank you. Thanks, everyone, and have a great Thanksgiving.
Yeah.
Thanks, Jay. It's good to see you.
Good to see you. Yeah, hi, how you doing?
Good.
It's been a while.
Yeah,
All right.
that was great though. Thank you so much.
Oh, thanks for the invitation. I appreciate it. Bye, everyone.
Okay. Bye.
I have a great weekend.
Yeah.
Thank you.